To you all. Welcome to this new video on the topic 8 queens problem. Eight queens problem. Eight queens problem is the problem of placing 8 queens on an 8x8 chessboard such that none of them attack one another. In 8x8 chessboard, we have 64 boxes or 64 squares, 64 cells. So the problem here is we have to keep all the 8 queens in each row so that none of them attack one another. That is, placing 8 queens on an 8x8 chessboard so that no 2 queens are in the same row or in the same column or on the same diagonal. So more generally, the n queens problem places n queens on an n by n or n cross n chessboard. So here, so if you have 8 queens, you have to place all the 8 queens in 8 rows. So n queen means it may be 1 queen, 2 queens, 3 queens, 4, etc. etc. So n queen problem, generally speaking, n queen problem. We can use backtracking algorithm to find the solution to the n queen problem. What is backtracking algorithm? You know about the greedy algorithm, dynamic programming algorithm, backtracking algorithm, exhaustive algorithm, Walsh-and-Bound algorithm. There are many algorithms out there. So here to solve this n queen problem, we are using backtracking. Backtracking is an intelligent way of gradually building the solution. Typically, it is applied to constraint satisfaction problems like Sudoku, crossword, 8 queen puzzles, chess, and many other games. Here consider for n is equal to 1, the problem has a trivial solution. n is equal to 1. So there are 1 row, 1 column, 1 queen. So we can place it here, queen. It is trivial. For n is equal to 2, and what is the solution for n is equal to 2? So there are 2 rows and 2 columns. First row, first column, second column, first row, second row. Here the queen 1 and 2. So here this 2 by 2 chessboard or 2 by 2 board does not have any solution because when you keep this queen here, what is the next queen to be placed? So here you cannot place the second queen here in this place because it will attack. If you place it here, this diagonally, okay, diagonal queen will attack. So if it is placed here, this queen will attack. So there is no solution for n is equal to 2. And even there is no solution for 3 by 3, n is equal to 3. If n is 3, there are n queens, 3 queens. So again, you are not having any kind of solution for 3. So here column 1, 2, 3, 1, 2, 3. Here if you place here, the second queen, you cannot place it here, and here you can place, yes. And the third one, here you cannot place, here also you cannot place, here also you cannot place. So there is no solution for n is equal to 3. So now let us consider the 4 queens problem and solve it by backtracking techniques. We'll try for 4. Since each of the 4 queens has to be placed in its own row, all we need to do is to assign a column for each queen on the board. Okay. So here 4 queens. So what is the step-by-step process for the backtracking algorithm to solve 4 queen problems? First step is start by placing a queen in the first column of the first row. So here there are 4 columns and 4 rows. So here queen 1, queen 2, queen 3, queen 4, right? So here column 1, column 2, column 3 and column 4. So first you have to try the queen, place the queen here. Okay, this is empty. Okay, initially the board is empty. So the first we will try, let us place the queen here. Okay, queen here. Okay, let us place the queen here. And next we have to check if placing the queen in the current position conflicts with any previously placed. This is the first time you are keeping the queen, no? So there is no conflict at all. Let us continue. So if the position is safe, move to the next column and repeat the process. So if the queen cannot be placed in any row or in the current column, backtrack to the previous column and move the queen to the next safe row. You have to continue this process for all, continues this process until all queens are placed or all configurations are exhausted. Okay, so we have to try for all the queens. So here let us consider this, well, the first queen is placed in here. So what it means, you cannot place the next queen in this, okay, or here. You cannot place this next queen in this row. Okay, so just put this into mark. The next queen cannot be placed here, third queen cannot be placed here, and also diagonal. You should not place the diagonal, place a queen on diagonal. So here, can you place the second queen in the first column? Definitely no. Second column, no. So here, no. Here also, no. Third, okay. Third column, can you place it in the third column? Is it possible? Yes. Here you can place it. So first, okay. So next one is, here you can place. Here you can place. So all the other you cannot do. So next thing is, so here third column can place third column. And first queen over, second queen over, the third queen, you are going for third queen, first, two, third queen. So you have placed it here, the third should be placed in the third row. Which column? Here you cannot have, here you cannot have because diagonal, here you cannot have because same column, here you cannot have because diagonal. Okay, so here it is not possible. Here it is not possible. So this you cannot put, and this you cannot put, this you cannot put. So all four columns, okay. So only the column 2 and 4 is free. So you cannot place the third queen in either the third column or second column or fourth column. So here, what is the next one is possible? So backtrack. So here you have no solution. So backtrack. So coming back to this. Okay, so one, here you have placed no. So this will be deleted. Coming back. So here you have another solution. You can place the second here. Instead of placing here, you can place it in the fourth column. So here you have, and the fourth column, you can have the second one. And the third one, you have to find the third. So third, you cannot place it in this column. You cannot, you can keep it here. So this one, and the second one, this one, the third one is here you can keep. So here, put another queen. Okay, so this is possible. This is not possible. This third column not possible. Fourth one, we have not tried. Anyway, in second column itself, the third queen can be placed. After that, the fourth queen. Okay, the fourth queen. How do we choose fourth queen? First column, you cannot. Second one, cannot. Third one also you cannot. Because here if you have this, the diagonal will be, so this is also not possible. The fourth one, definitely not possible because already this column contains. So you cannot proceed like this. So backtrack. Okay, and backtrack. The second queen, all the columns we have tried. First, second, third, fourth. So go back. So we have to find to put this first queen in some other cell or some other cell. So 1 is okay. So let us try for this position. 2. This position is for the column 2. So let us place here. Okay, backtrack. We have kept it in the first row, first column. It's not working. So go back to this. Okay, go back to this. So this is first queen. So the next second queen, where it has to be. So here it is it possible to place it in the first column? First column, second queen? No, it is not. It's not because diagonal. So this is, and of course this is not possible because already this column. Can you have the second queen in the third column? So here you cannot, here also you cannot, but here you can. Yes, here you can. So here you can have. So here, second queen, second queen, here, no, yes, here you can. So now let us have this. Okay. So this one is possible. And next from this, the third queen has to be placed. Third queen, second queen we have placed, first queen we have placed, then third queen. Third is third row. So in third row, for third queen, first column, is it possible? Yes, it is possible. Here you can have this. Okay, here you can have. So already we have this, and third one is here. Third one, this. And next fourth one, third. Okay, the fourth queen. How do we place the fourth queen? So, fourth queen, no, yes, here you can have, yes, here you can have. So, already the format is there. Okay, so the fourth queen can be placed here, you can see. Okay, so now this is the final board in which all the 4 queens are placed very safely. So here there is no attack. There is no queen in the same row, same column, or also in the diagonal. There is no. But consider this one. It is also in safe position because there is no queen in this column. There is no queen in this row. There is no queen diagonally. And this is all the others are same. So this is the stage 3 for solving the 4 queens problem by backtracking. If anything happens, backtrack, delete, undo the operations. Start from fresh, from the next optional stage. So the solution for the 4 queen problem is 4 tuples, x1, x2, x3, and x4, where x3 represents the column number of queens. You have 2 possible solutions for 4 queen problems are there. Only 2 possible solutions, but combinations are more. Okay, 4 into 4. How do we find the combinations for this? How many number of cells are there? 16, 3, 4. This is queen. This is the queen number, and this is the total number of positions. So 16 C4 means NCR. It is n factorial divided by r factorial into n minus r factorial. Okay. So 16 factorial divided by 4 factorial into n minus r factorial means 16 minus 4, 12 factorial, which is equal to 16 into 15 into 14 into 13 into 12 factorial. Okay, divided by 4 into 3 into 2 into 12 factorial. So these 2 will get cancelled, and 4 4s are then 3, 5, 5, 5 3s are, then this one, 2, 2, 7. Okay, so the multiples of these three, okay, 4 into 5 into 7 into 13. So that many number of combinations are there. 16, 15, 14, 13, 12 factorial get cancelled. 4 into 3. Okay, 4 4s are 16, 5 3s are 7. Okay, 4 into 5 into 7 into 13 combinations are there. So what are the two possible solutions in this 4 by 4? Listen. So here 1. This is one solution. And here you can have it here. So this is another solution. This is another solution. Okay, there are only two solutions exist for 4 by 2. Okay. So here 18 problems. Consider. So we will try and we will solve it only with the simple steps. So I'll give you only some steps and you should proceed. Okay. So let us try. The very first one is 1. So this is 1 by 1. Place it here. So place it here means all the others you cannot place. Right? You cannot place. So the next loop will not consider this first row, first column and also diagonal. How do you find the diagonal index? So if this is 1, 1, this is 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, that's it. Okay. So for the second thing, here you cannot, here you cannot, here you can have, here you can have. Okay. So let us have this. So if you keep a queen here, then you should not consider this. Okay, instead of putting star, I am putting this line. So already you cannot place it here. And also diagonal. Here also you cannot keep a queen. Then third queen. Third queen will be placed in the third row. In which column? So here you can have. Okay. But here you cannot have because this is diagonal. No, I forgot. Okay. Here also you cannot put. Only this position you can try. So this 3. Okay. If you keep, then you should not, you are not supposed to consider this column. Right? And also this diagonal. This diagonal. And fourth one is, you can have it here. Okay, you can have it here. Of course, is it possible? Yeah, it is possible. You can have it here. If you have this queen, then you cannot have the queen in this. Already, this is blocked. Here you cannot. Okay, and diagonal. Diagonal means already this is blocked and this is blocked. So this will be blocked and already this way is blocked. So here blocked. The fifth queen, how do we get? So here it is possible for fifth it is possible, but whereas already you have this, no, this diagonal, okay, fifth here you can have it. Here you can have it, yes. So diagonally, it is blocked. So you cannot have queen in this place. You cannot have the queen in this place. And you cannot have the queen in this place. And sixth is not at all possible. Listen, you cannot keep the sixth queen in this sixth row. So backtrack. So you should find a correct position to keep this fifth one. So instead of this fifth one, you should change the position. So once for all, you have to backtrack and keep this position to some other. Then if it is not working, change the position of fourth one. If it is also not working, change this position of 3. And if it is not working, change position of 2. It goes on like that, backtracking. Okay. So now, in this way you have to proceed. Anyway, I'll give you the solution. Final solution, we'll see the final solution. Okay. I could have got another table. Okay, anyway. Kindly bear with me. Okay, so the correct position or for this queen is given. The first one, the second row, fifth column. Second row, fifth column. Here you can have third row, last column. Fourth row, sixth column. Fifth row, second column. Third column. Which one? Fifth row. Okay, third column, sixth row, seventh column, seventh row, second one, and eighth, fourth. Okay, so now let us see the position. So here it is in safe because there is no. Okay, and the second one is also safe because there is no. Diagonally there is no. So something like that. Okay, and here there is no. And for this fourth, there is no queen in this row. There is no queen in this column. There is no queen in this diagonal. And fourth one, there is no queen in this row. Something like so. All queens are in safe position. There is no. So this is how the backtracking is working. 8 queen problems has NCR 64C8. Okay, is equal to some number is given. That many number of different arrangements are there. So out of these, only 92 arrangements are valid solutions. Out of which only 12 are the fundamental solutions. The remaining 82 solutions can be generated using reflection. Reflection is nothing but you can rotate this one, you can rotate this board and you can see first queen can be placed in the third column, the second one in the sixth column, something like. So the original, okay, is 12 or fundamental solution. And here the number of queen 1, the trivial solution 1, 2, 0, 3, 0. If you have 4 queens, 2 possible solutions. If you have 8, you have 92. If you have 14, it goes on like that. So this is how you solve the 8 queens problem. Thank you. So if you want to see the C program, okay, the algorithm, first algorithm. This algorithm is shown here. Solve queens. So initially, function start queens. Initially, n by n board. All will be initialized to 0. You have to solve these queens. Okay, if it has the solution, it will print the board. If it does not have solution, then it will print no solution exists. So how do we check whether position of the queen is in safe or not? For I is equal to 0 to row minus 1, 0 to 7. Okay, there are 8. If board of I comma column is equal to 1. Okay, if already is any queen is there in the column, it has to return false. That queen, the new queen which is placed in that column is not in safe. If it is in the same row, it is not in the safe. If it is same column, it is also not in the safe position. If they are not, if the new queen placed in a particular cell, in a particular row and column, if none of the queen is in the same row, same column or on the diagonal, it will return true. If it is in safe, proceed with the another one. Next board from I is equal to column from 0 to n minus 1. We have to find whether it is in safe or not. Okay. So now the program. So this is the program in C. Okay, now let us execute this. Okay. Alt R, Alt F5. Okay. So this is how. See, listen. This is solution 1. Okay, the queen for 8 row 8 columns, queen 2, and this next queen is placed in 5th column, next 6th column, something like. So similarly, here you can have say 92 solutions. Okay, 92 solutions. I have not. I have printed only one solution. If you want to have all 92, then you can have it by. Okay, all 92 possible solutions are printing here. So you just convert that algorithm into C or C++ program, then you can execute and find the solution. So thank you so much. Hope you have understood this backtracking algorithm to solve 8 quiz problem. Similarly, you can try for other options also. Thank you.